In this video, we will explore how to select the most suitable type of investigation to answer a specific scientific question and analyze why certain types of investigations are appropriate or inappropriate for testing a particular hypothesis. A group of Year 11 students discussed whether chemical reactions occur faster when the temperature increases, while learning about the particle nature of matter. Particles in all states of matter are in constant motion. In solids, particles vibrate in their fixed positions, while in liquids and gases, they move more freely when a substance is heated. Its particles absorb energy, increasing their kinetic energy and making them move faster. A chemical reaction occurs when reactant particles collide with sufficient energy and the correct orientation to break and form new bonds. This required energy is known as the activation energy. When the temperature of the reactants increases, the particles move more rapidly and collide more frequently. More importantly, a greater proportion of collisions will have enough energy to overcome the activation energy barrier, leading to a higher reaction rate. With this understanding, the students formulated the following hypothesis. Increasing temperature increases the reaction rate. The next step is to choose the right type of investigation. The purpose of the investigation is to determine the effect of temperature on the rate of reaction. So, they chose magnesium ribbon and hydrochloric acid reaction as their chemicals to investigate. They took 4 test tubes and measured out 10 milliliters of dilute hydrochloric acid in each tube. They numbered test tubes 1 to 4. They then took 4 200 milliliters beakers. They numbered the beakers as well. In beaker 1, they put a few ice cubes. In beaker 2, they put tap water. In beaker 3, they put warm water. And in beaker 4, they poured in boiling water. They then placed the test tube 1 in melting ice in beaker 1. The second test tube in the second beaker with tap water. The third test tube in the third beaker with warm water. And the fourth test tube in boiling water in beaker 4. Each test tube was then placed into its corresponding beaker and left for 10 minutes to allow the acid to reach the same temperature as the surrounding water. After this period, the temperature of the acid in each test tube was measured and recorded using a thermometer. Next, the magnesium ribbon was cut into 1 centimeter pieces to ensure consistency. A stopwatch was prepared to measure the reaction time. The experiment was conducted as follows. A piece of magnesium ribbon was added to test tube 1, which contains cold acid, and the stopwatch was started simultaneously. The bubbling caused by hydrogen gas production was observed. When bubbling ceased, indicating the reaction had completed, the time was recorded. This process was repeated for test tubes 2, 3, and 4, each containing acid at different temperatures. To ensure reliable results, the experiment was repeated 3 times for each temperature condition, and the average reaction time was calculated. A column graph illustrating the relationship between temperature and reaction rate was created to clearly represent the data. After analyzing the results, they concluded that the reaction rate between magnesium and dilute hydrochloric acid increases as the temperature of the acid rises, confirming their initial hypothesis. This investigation is considered a fair test because it ensures that only one variable, the temperature of the acid, is changed while all other factors remain constant. So, the independent variable in this investigation is the temperature of the hydrochloric acid. All other factors that will affect the outcome of the investigation must be controlled. These controlled variables include the concentration and the volume of hydrochloric acid in each test tube, the mass and the size of the magnesium ribbon used, the method of measuring the reaction time using a stopwatch, the way temperature is controlled using beakers with different water temperatures, and the number of repetitions to improve reliability. The dependent variable, what is being observed and measured, is the time taken for the reaction to complete. A fair test is essential for obtaining reliable and valid results. by keeping all other factors the same and changing only the acid temperature. This experiment ensures that any differences in reaction rate are due to temperature alone and not other uncontrolled variables. This makes it a fair test and allows for accurate conclusions to be drawn. A fair test is the most appropriate type of investigation for this situation, because it ensures a clear and reliable determination of the relationship between temperature and reaction rate. By changing only one variable, while keeping all other factors constant, the experiment ensures that any observed differences in reaction rate are solely due to temperature changes and not influenced by other variables. This controlled approach eliminates bias and improves the accuracy of the results. Additionally, repeating the experiment multiple times and averaging the data enhances reliability. Reducing the impact of random errors, a fair test provides strong scientific evidence to support conclusions, making it the best method for investigating cause and effect relationships in chemical reactions. Other types of investigations, such as pattern seeking, modeling, or identifying and grouping, are not appropriate for testing this hypothesis, because they do not provide a controlled way to establish a cause and effect relationship between temperature and reaction rate. Pattern-seeking investigations look for trends or correlations in naturally occurring data, but do not involve direct manipulation of variables. In this experiment, we need to deliberately change the temperature and measure its effect on the reaction rate, which pattern-seeking does not allow. Modeling is not appropriate for this investigation, because it involves creating representations or simulations of real-world processes, rather than directly measuring and observing the actual reaction. While models can help visualize concepts, like particle movement and collision theory, they cannot provide measurable data on how temperature affects the reaction rate. Since this experiment requires precise measurements of reaction time under controlled conditions, a fair test is the most suitable approach. A fair test is the best approach because it ensures that temperature is the only factor affecting the reaction, allowing for accurate and reliable results. Thanks for watching. Stay tuned for another informative science video coming soon. In the meantime, keep exploring and enjoy learning.